Alright, we're writing general equations for these things. One of the things that I want to make sure that we're recognizing is parabola is something squared, which you know. Cubic is what it sounds like. It's something cubed. Absolute value, we should know. And square root is new, not the idea of square root, but the graph of it. And so what you should have figured out from today is that if you want to move something left or right, it's always inside, hanging out with x, being affected by the particular operation. So specifically, if I want to move it right, I'm going to put a negative. If I want to move it to the negative side, I'm going to put a positive. So the way we state that is opposite of the number. The y is equal to this. So if I want to make the y go up, I'm going to add something. If I'm going to make the y go down, I'm going to subtract something. But this is where it goes on the outside here, because I'm going to take whatever I have and then I'm just going to make it go up, because that, again, this affects directly the y there. The last thing is your a value. And this one here, remember, makes it go up or down, and then also makes it go wider or narrower. So the beauty about parent graphs is that if you have a general sense of what each of these look like, then the h and the k and the a do exactly the same thing for each. So let's go ahead and look at what that means. So first of all, this says it's going to be a cubic. So I'm just going to get everything ready. This one's going to be a square root. I'm going to get everything ready. And this is going to be absolute value, so I'm going to get everything ready. The vertex and the locator point are your h's and your k's. So the h, let me put my x's in here, is opposite. My k is just regular. My h is opposite. And my k is just regular. And my h is opposite. And my k is just regular. This is a cubic. So after I get my locator point of 3, 2, my cubic, if I cube 1, I get 1. If I cube 2, I get 8. So it starts in close, so then really kind of shoots down there. For my square root, first of all, this also said upside down. So I had the locator point, but I haven't accomplished upside down yet. And negative will flip it. So in other words, if it's normally going up like this, and I want my y's to all go the opposite way, I just put a negative there and everything will flip upside down. So let's look at this. Negative 2, 1 is my locator point, and it would normally go up, so now it's going to go down. In terms of the normal values, I'm going to put that in a different color. It would normally go up, and then if you plugged in 4, the square root of 4 is 2, and the square root of 9 is 3. So that's where it would normally go. But I'm flipping it. So I've got this sort of look here. So it's just the red stuff. And then the absolute value, my vertex is at 1, negative 4. It's not going upside down or anything. It doesn't say anything about my slope, so I would assume it just has this normal slope of 1 to begin with. So that will be our graph. So continuing on in the same vein, if this is the graph that you start with, which the vertex would be at 0, negative 2, and it shifts to a new position, so the vertex is now at negative 7, 5. Now, because these things are opposite, and you're also trying to figure out where one thing is going to the next, state what the vertex are, the locator point is, because then this directionality won't get all jumbled, because you don't have to do too many things at once in your head. So I'm going from a 0 to a negative 7 in the x direction, which means I'm going to the left 7. And then I was down here at negative 2, and now I'm going to be up here at 5, so I'm going to go up a total of 5. So it looks like up 7, left 7, that this would be the 1. For a cubic, we still just need to kind of figure out where it was originally. So my locator point is at negative 2 comma 3. And then I'm going to shift it down 4, so it was at 3, now it's going to be at negative 1. To the right 6, so it was at negative 2, and I'm going to go 6, which is going to be over here at positive 4. Give yourself a visual if you need to figure it out, because again, you really kind of have to, it's all about where things are moving, so you need to have a visual of that. So first of all these are cubic, so I don't need to worry about that. This is my new locator point that I'm looking for. This is where the K goes. This is the opposite of the H. So that would be it.